Okay, thank you so much. Thank you. Okay, so since I don't have to shout for so much for the entire hour. Yay! That's it. Let's get into it. Well, okay, yeah, let's get into it. So again, let's get back to our deal on Java, right? So we got to do this in less than an hour. So one thing to note, if you want to learn more about Java beyond what I mentioned here, there are a few ways you can do it. You can Google, you can see CS2040S if you're taking the module. There is an optional textbook that we can use for this, but we won't go into too many advanced features. What do I mean by advanced features? You might know about lambda expressions. Maybe this is a concept you're familiar with from CS2040S. I'm not sure, but I don't know what they call it. But the point is these sort of advanced features, stuff like lambda expressions, stuff like type inference, right? Stuff like this, stuff like all the different types of ways you can create your methods and stuff. These are what we might consider Java advanced features. What 2030 might consider basic, I don't know, right? But here's my advice for our module. Again, slightly counterintuitive, but maybe try not to use the advanced features. Here are my reasons why. Okay, typically these advanced features are there for you to make your code shorter. Okay, in other words, there is sort of very little extra functionality, and oftentimes it kind of hides what's actually happening under the hood. Now, why is that not great for CS2040S? Because we need to know sometimes for ourselves what we are implementing, what is under the hood. How else do we know how efficient it is, right? Sometimes the implementation details matter. Okay, it is true that it might make the code harder to read, right? Make the code easier to read. It might make it harder to read depending on your level of proficiency, right? In general, once you're more proficient with Java, you might say, okay, I want to use these things because it makes the code short. It makes it very easy to read for me, right? But oftentimes it complicates things. Okay, so I would argue that one of the some of the few many goals that you have in writing code would be to write it correct and bug-free. This is something that we talked about, right? Hopefully you make it easy and readable and easy to understand, right? And definitely we want it to be efficient. That's the goal of CS2040S, right? And of course, your code should be submitted by the deadline. Hopefully that we don't keep mentioning that, but to hammer home the point. And it should be really far down your list of priorities of how your code should be that it should be short at this stage. Yeah, we need to know what you're doing. You need to know what you're doing with your code, right? So the advice here is to make your code intentional, right? So some stuff we will mention, but for example, don't try to rely on default or non-explicit behavior. I'll show you some examples of that later. Okay? Some more advice. Try to use the IntelliJ debugger. So I will mention this. Personally speaking, I've not really used IntelliJ's debugger, but that's also because beyond the courses that I took where they needed Java, I moved on to C and C++. So I have my own debuggers. I use GDB and Valgrind and stuff, right? I have used this, I think, when I took my version of 2040S. It used to be called 1010. It used to be called 2010. Yeah? And it was super helpful when I was debugging trees, so maybe it might be helpful for you as well. These things you can look up and you can Google, but my point is to tell you that it exists. There are buttons you can click, and you can look at videos that tell you how to do this stuff, right? It helps you step through your code. Maybe you don't know at which point did your code break. Walking through this and tracing through the steps and looking at the states will be super helpful for figuring out where you went wrong. Okay. So again, today's goal, we're gonna try to make you aware of a few key aspects of Java. And after class, I encourage you to look things up. Right? There's an after class after lecture review. Okay. So again, the basics of OOP and Java. So I don't know how many programming paradigms you know. I think in 2030S they'll teach you some, hopefully. I didn't set the syllabus, so I wouldn't know, right? But you might have heard of some of these things. You might have heard your seniors talk about it. You might have Googled it before. Stuff about procedural languages, functional languages. I think like O1S, you probably know functional a bit better than I do, actually. Declarative stuff, object-oriented stuff, right? So all these ways of writing code, it just depends on how you want to structure your ideas, right? So Java and C++ are examples of object-oriented languages, and some of the reasons why we want to use them is because, why we want to teach you these things is because Java is kind of, maybe for better or for worse, is kind of near ubiquitous in the industry. So it's really hard to find jobs that don't ask for some amount of Java experience, especially in the banking industry. Like most banks somehow, for some reason, love Java. I have no idea why, but they do. There's a lot of reasons that people can go into. You could debate with me if you're a language nerd. I'm not that much of a language nerd, but stuff like how modular it is, like how it helps with code reuse and stuff like that, right? So let me try to sell you on the OOP paradigm for a bit. But generally, there are 4 principles. Abstraction, which I think you guys might know, hopefully, right? Encapsulation, inheritance, and polymorphism. So one thing to note, right? Let me talk about some of these things in detail. Abstraction, you guys might know it to some degree, but in some ways, you can think of this as basically trying to have a separate interface between two things, right? Two concepts. One is the implementation versus what we want from it, what it's supposed to do, right? So on one side of the line, one side of this line, one person might look at it and say, okay, I know what it's supposed to do. I know what behavior it's supposed to exhibit. I don't care how it does it, right? On the other side of the line, the other person is more concerned with its implementation. That's what abstraction means, okay? Encapsulation, on the other hand, means that if we want to hide the implementation and only make the interface publicly visible, right? So think of this as basically saying whatever you need to know, you know. Whatever you don't need to know, you don't know, right? And for example, in OP-based language like Java, we have a few more things to talk about. For example, inheritance. This is something you might hear down the semester. Don't worry too much about it now. But basically, in a few lines, it's basically saying that we can build new classes by extending off previous classes. This helps you, for example, prevent code reuse, right? One way of doing that. The other thing, for example, is polymorphism. This is something you might hear a lot in Java as well. It's talking about how if you have the same interface, but you have different behaviors, right, based on the context, then that's something that we will fall under polymorphism. Now, I know this might sound super intimidating, but let me just simplify it for you a little bit. The first two things are very relevant to CS2040S. Now, I'll try to sell you the idea why in a bit, right? The last two things, less relevant, definitely important overall. And those things you might see in CS2030S. But I don't want to do the lecture content for them, so we'll focus on the first two and not the last two. All right, so put yourself in this scenario, for example. Let's say that we had this dude, Naruto. It wasn't me who made these slides, by the way, so I hope Japan doesn't sue me. Okay, but like think of it this way. Let's say there's this new hire Naruto, right? And for example, maybe we might think he's a nice guy, really likes bananas, right? Maybe not the smartest fellow, but we really like him because he's really friendly, right? But the concerning thing is that we're afraid that he's going to screw up our code, man, right? So what should we do? Right, so some of the things we could do would be to give him pointless work. We could send him back to the forest. But we kind of want Naruto to work on our project, right? And we still, at the same time, don't really want him to destroy our project either, right? So how do we do this? Well, one way to do it is to use abstraction, right? So again, in a few words, we basically want to remove all the unnecessary elements, right? Okay, whatever Naruto needs to know to do his job, we give it to him. Whatever he doesn't know, we hide away from him. As long as he doesn't have access to it, hopefully it's fine. Right? So in a picture, this is what it might look like. Maybe we are the ones with the black hat. Maybe we are Naruto. I'm not sure. Right? But basically, in a nutshell, it's when, in an object-oriented language like Java, basically we have an object, right? It exposes a public interface to Naruto. Naruto is going to use everything on the public interface, whereas the implementer basically deals with the implementation and the private data. Okay? So here's the claim. We are all kind of actually Naruto. Okay? Why? So software has been getting very complex. I mean, you guys are born pretty young. I would like to think I'm kind of relatively young compared to my seniors as well. But basically, back then, code used to be kind of small, right? Like, okay, I know the picture's like really small. It's really hard to see, right? But like basically, long ago, right? These parts of software used to be like really, really small. Nowadays, on the other hand, we're sort of like bordering on like 100 million lines of code, 2 billion lines of code, and stuff like that. Right? Do you really need to know the entire project to contribute to the whole thing overall? I'd argue not really. In fact, it's not feasible. Right? Software is getting really complex. Right? So for example, if we ask how many lines of code are there in Google as of 2016, which is about, 8 years ago now? 8, right? You have like 86 terabytes worth of data, like in terms of like commits and code alone, right? Should you be expected to read through everything before you start working on Google Code? Definitely not. Right? So how do we do this? The point is that everyone is kind of like Naruto, and we always only expose to them the things that they know, they need to know, right? This way, the amount of like mental load you need to take to be able to use things, to be able to work on things is a bit smaller. Does that make sense? Good? Yeah? Anyway, in a nutshell, it's to save us from ourselves in some sense. Think about it this way. I'm pretty sure you've all thought about this before, but when you wrote code to say print on the screen or like make this image, you weren't really like you didn't really have to care or worry about how that was done, right? You just said let it be done and like do it like this and then just did it, right? Same thing here, right? Okay, so abstraction, something that they might mention in software engineering. I'll tell you how this works in CS2040S in a bit, right? But basically, in software engineering, the way that it's helpful is that basically you can take a really big problem, like let's say, how do I handle Google search? And I can break it up into multiple parts, right? Someone has to deal with the internet protocol, someone has to deal with the website front end, someone has to deal with the server back end, stuff like that, right? We divide them up into components, and how do we decide on the border who deals with what, right? We use interfaces. We'll talk a little bit more about that later on, right? But think of this as the way to agree upon what's your job and what's my job. Right? And then in software engineering, it's common that after that, you assign teams to build each component. And if each component is still too big, you make smaller teams, so on and so forth, and you recurse, right? So this sort of idea is sort of like you have the big picture, like the whole architecture first, right? Identify each component, and then say, this team does this team does that, yada, 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 keep going down until like the job is feasible. Okay, well, in algorithm design, it's kind of really similar, where we have really big problems that we want to solve, because those are the ones that we care about, right? And we should break them down into small components, okay? And one of the ways to do that is to sort of define an interface between components, okay? And again, we'll show you how to do that in Java in a bit, okay? Then the idea is to solve each problem separately, recurse, right? And then combine the solutions later on. Sound familiar? Hopefully it does. Okay, so let's go back. Let's go to OOP. So hopefully I've sold you on the idea. If I've not, please sell yourself on the idea, because there's no more selling that's going to be happening here. Now we're going to talk about OOP, right? So in OOP, there's sort of like two sort of like rough things you need to take note of. An object is something that has two things. It has state and it has behavior. Okay? Think of state as basically the data that you're going to manipulate. Okay? Think of behavior as basically specifying how that data is going to be manipulated. So for example, we could have a classroom object, right? And for example, in a classroom, we might want to care about a few things. So in terms of data, we might have a list of students, we might have the number of chairs, and maybe let's just say for some reason we also want to know about the temperature, like at the classroom at that point in time, right? So these things will be put under data, right? But what about the behaviors of the classroom? There are a few things we might want to do. For example, we might want to sort of quote-unquote manipulate the classroom by entering students or noting when students leave, stuff like that. So we would, like the stuff in blue, we would write that as behavior. But behaviors don't just necessarily have to manipulate data. It could also just be to access data, right? So for example, when you use count, you might be getting the number of students. I don't know. It depends on what the name is trying to say, right? But again, TLDR, there's like two things that are going on here. Okay? So let's think a little bit, for example, about how to try to apply OOP to implementing a file system, right? Let's say that there are 4 options here for you on how you should create the objects, right? So in other words, I'm asking you, if we want to implement a file system and we want to think of this in terms of objects, right? Which of these 4 options do we think apply like the best? I'll give you guys like a few seconds to think about it. Again, sorry, it's like I tried pacing myself, so this is like the best I can do. Right, so who thinks option 1 is like good? Who thinks option 2 is good? Who thinks option 3 is good? Okay, what about option 4? Okay, quite a lot more hands. Okay, so one thing to note before I talk about the solution, right? It is true that what I'm going to say here is a bit subjective. So some people might disagree with me. Maybe you know like the senior engineer at Google or Facebook, and they'll tell you a different story. They're probably right. So in general, the answer actually still is it depends. But in general, here's the easiest rule of thumb to sort of try to follow, right? Let me try to explain why option 1 is not exactly the best option, right? So the idea is that as a general rule, when you're starting out, the easiest way to see it is that objects should represent state, not actions, right? So in option 1, when we had this file management object, that seems more like a verby thing, right? We want to specify behaviors by the object, not using an object itself, okay? So in option 2, for example, if I only have a file object and I don't have folders, is it really a file system? We're sort of missing one object, right? So we still need another object for that. So I think that hopefully kind of hints at you that we are actually looking for option number 4. But let's talk about option number 3. So the thing about option number 3 here is that objects should be unitary. They should not be dividing functionality. It's a bit hard to sort of tell you how the divide happens. Hopefully you get more experience as you go along. But rule of thumb to bear in mind for now. So we're actually happy with option number 4, right? Because we have 2 objects, and they basically are the divide that we are looking for. We have an object for files, and we have an object for folders, right? So again, like I mentioned, objects have 2 things that we have to talk about, the data as well as the behavior, right? So let's look at that. So for files, for example, right? Okay, I know data is a generic term. And by the way, if you ever start writing your variable name saying like data this, data that, I've heard from my friends that who are like mentors and like senior lead engineers now, they get very annoyed when when like new hires write data as like the variable name for everything. So maybe avoid that, right? But in general, it is kind of true that files contain like generic data. It actually contains generic data that we have to deal with. So that's one of the things that we should put in our object, right? In terms of behavior, right, we would have to think about, for example, should the file be edited? Can it be renamed? Can it be moved? Stuff like that. That we put under the behavior category for the file object. Does that make sense? Right? Extrapolating from that, let's try the folders object instead, right? I'd argue it should contain a few things. It should contain files. That's an object, right? That's data. It should contain folders. That's also data. And maybe other behaviors that you might want to provide are the same thing. You might want to rename it or move it. There could be more, by the way. This is not an exhaustive list. It's just an example. Does that make sense? So there's two things here that you have to worry about. Okay? So the first principle of Java, maybe to simplify things, is that everything is an object, right? You're an object, I'm an object, everything is an object. So one thing you might come up and ask to us is that, like Java 8 onwards, like, it's kind of functional, right? We have like lambda expressions, we have anonymous functions and all this stuff. Like, I don't know if they have like higher order stuff. I think they do. They have predicates and all this like really nice things, okay? But just so you know, under the hood to Java, these are actually all just objects. So there's nothing contradictory about what I've just said. Everything really is an object to Java. Yeah? And the way that we would try to specify what an object is to use something called a class. Okay, so let me explain this. So how do we make an object? Hopefully I've sold you on that idea, but how do we make an object? Here's the code that we would write in Java. Okay, you don't have to scribble this down, by the way. Again, like I said, I'm going to be releasing the slides, right? But just pay attention to the syntax for now. You start the first line with class, space, followed by the name of the class that you want to make, right? So for example, let's say we want to make a file object, right? We would write class, space, file, uppercase, please, okay? Do your open and close curly braces, and then over here in our code, we would start writing a few things. Now, if you remember, like I mentioned, right, we have the file contents as well as the name as our data types, right? So on the second, I guess the third, right, because the curly brace is one line as well. So on the third and the fourth line, right, we sort of specify the data of our object there, right? So in this case, we have two data types that we need. One for a string, which is the name, and maybe let's say one for, like we'll call it file data. It basically stores the contents of the file. This is the data of our object. Does that make sense? Okay. It just randomly hit me that like if you guys watch this back on like the recording, and if it is recorded, I wonder how many of you are gonna have to do like 0.5 instead of 2x. Like, okay, that was a random thought. Okay, like that happens to me sometimes. I have to stop doing that. Okay. Anyway, let's get back. So besides data, there's another thing called behaviors, right? So how do we specify that? The idea on how to do that is to specify functions. So the last three lines that, let's call it the last three lines. Like, let's not be pedantic. The last three lines that you see in blue, right? Those are basically how you specify your functions. These are your function signatures. Okay? I know it looks a bit intimidating for now. If you don't know what types are, we'll get into that in a little bit. But the point is that the first two blue lines, data. The last three blue lines, behaviors. Right? The last three blue lines are your functions, right? Think of it that way. Okay? Now, to be clear, you can't just copy-paste this verbatim in Java and hope that it compiles. We've put dot here. That's not Java syntax, right? I'm just shortening it so it fits on the screen for you. Make sense? Okay? Okay, so like I mentioned, again, if you want to define a class, you need to specify the class name right after the class word. So class is a keyword, right? CLASS is a keyword. Okay, file is the name that you specify. Okay? The name of the class, one more thing. So when you save this into a file, please save this into file.java. Apparently, it's convention that Java like insisted on. It's, if you ask me why, I'm not a Java creator, so I don't know like why they did that. Yeah? Okay, so a few things to note. For example, if we wrote equal, let's say like empty string and equals now, for example, right? This is what's going to happen. Like the variables will be initialized here when defined first, right? So in other words, when you create the object, right, the variables there will be initialized to the values after the equal sign. Okay? Now, that's it. If you came up to me and you asked me, what happens if I don't specify this? Will it be fine? Because the Java compiler is allowing it and the code seems to compile. Yes, technically speaking, it is allowed, right? And what's going to happen is that it will default initialize these to some values. Maybe. It depends, right? Do you see how I said maybe right there and I said it depends? That's a sign of ambiguity. We want to avoid this. So again, general advice. Try not to rely on defaults for now. Be explicit. Until you're familiar with actual default Java behavior, maybe then you can be more comfortable not relying on explicit behavior. Does that make sense? Right? I know it means you have to start writing a lot more code and typing a lot more characters, but my point is that being explicit helps you be very clear on what's going on. Okay? So, next thing to note, moving beyond the variables, let's talk about the functions now, right? I mean, well, let's look at the functions for a little bit. For example, let's look at rename. Rename seems to have some funny words in front of it, like void, rename, string, new name. What's that doing, right? What is that doing there? So the second principle of Java, everything has a type. Okay? So what does this mean? For example, you might already have some experience with Java, or maybe halfway down the semester you come and ask me, hey, there's this thing called var, like why can't I use that instead? To be clear, in Java, there is still a type. Sometimes it just guesses it for you, right? So what I mean by this is the following. If you wrote the code int j equals to 7, right, you can't after that write j equals to string 7. These aren't the same type. An integer is not a string. Do we agree? Does that make sense? You might have been able to do, there are some languages where you can do this, right? So like JavaScript, I think you can. Python, I think you can. TypeScript, maybe not. It has type in its name after all, right? But you definitely can't do it in Java, right? So one thing, for example, you might try to do, for example, say var j is equals to 7, right? And then subsequently after that, write j is equals to like string 7. That's still not allowed. Right? That's still not allowed, and the reason why is because on the very first line, when you wrote var j is equals to 7, what actually happened here is that Java guessed the type for you, and it guessed it to be an integer. Okay? And from that point onwards, it will always be an integer. Okay? So it doesn't change. Again, maybe try not to use var. Okay? So advice, always specify the type. Please don't rely on type inference. I know at some point, some of you are going to be rushing for a deadline, and you're going to be like, I don't have time to write string. I'm just going to var everything. And you might introduce a few bugs. So my advice to that would be, do the problem sets early. Don't do them 5 minutes before the deadline, yeah? Okay. So more about types. Now I've actually highlighted like the words here, and you might see what it means, right? So for example, in front of your variables, you have to specify what the type is, right? In front of your functions, you need to specify the return type. Does anyone know what it means when we write void? What does it mean about the function? It doesn't return anything. Great, exactly, right? So if you write void in front of the name of a function, it doesn't return anything, right? If you want to specify the type of your inputs, for example, that it takes in a string, do that. Write string new name. Yeah? Okay, so on the topic of strings, let's talk about strings for a little bit. For example, let's say you want to create a string. One way to do that would be to write the type first, which is string. Right? This means that str is a variable, right? The variable name is str, and the type of the variable is string, right? And you can initialize it by writing equals the text that you want to write. Okay? There is a different way of writing it, which is the second line, which is to say equals to new string. Okay? Now, slightly counterintuitive. Why would we write it like this? Right? That's what we call a constructor. We'll get into that in a little bit, but the point is that it's a thing. You can do it. Okay? Few things to note. For example, string is an object, which means not only does it have data, it also has behaviors, right? So, consistent with what I've said, there are these standard behaviors that you can invoke well, it's thanks to the Java standard library, right? So, for example, you can call charadd, you can call substring, you can call toCharArray, you can call length. These are things that you can do, okay? Now, there's definitely more methods that you can use. You can look up this web page. I think it shouldn't be 11, it should be 21. That might be a typo, but I'll correct it before I post the slides. But basically, these are functions that you can definitely call. And these will do, hopefully, what you think it does, right? The name should be super descriptive. Always write descriptive names. Descriptive variable names, descriptive function names. Always do that, all right? I only corrected this one. I didn't correct the previous one. Okay, that's why that happened, right? So for example, if you want to compare strings, you can use these functions instead. You can use compare to, you can use compare to ignore case, stuff like that, right? These are all things that the Java standard library has provided for you. And it might be really nice to use strings because, for example, if you want to append, let's say, the character C, we've talked about this a bit, I was going to say last week, but the week hasn't ended yet. 2 days ago, right, where what you can do is just use the plus symbol, right? But hopefully we all know this is expensive because every time you do this, you have to copy out the original string, put in the new character, and that becomes a new string, yeah? So use this thing carefully, please. I think this behavior might be specified in the documentation as well. So get used to reading documentation. I mean, we're all going to be engineers, and engineers always read documentation, so, get used to it. Okay, one thing I will mention, here's a common bug. You might make 2 strings, right? For example, let's say you have one string with a variable my name, and you initialize it with the name Seth, right? And a second object, a second string with the same string contents. What do you think happens if we use the double equal sign? It might not be the same. It might not be the same object. This might not evaluate to true. The reason for that is that the double equal sign is comparing whether they are the same object, not whether the string contents are the same. There is a difference here. Does that make sense? Okay? Okay, so just to round up, that was about types. Okay? Now, let's sort of like focus on so for a class, like I mentioned, there are a few things to take note of, right? These are what we call member variables. You can also call them instance variables. Think of these as the variables that belong to the object. Every time you create an object, it comes with these things that you can manipulate. Yeah? To manipulate them, we want to use these functions, right? These are what we call methods. Okay? In case you're curious and you ask me now, why do we call them methods rather than functions? It's kind of common and typical, someone might correct me on this, but it's kind of common and typical that basically functions are sort of like free-running functions that aren't tied to specific objects or classes or like stuff like that, right? Functions that are basically specific to classes or objects, we call them functions. We call them methods. We call them methods. Yeah? Okay, so rounding up, this is how you define a class in Java. Let's go through another example, right? So, for example, we're done with the file class. Maybe we want to talk about the folder class, right? So again, class folder, please say this in a folder.java file. Don't say this in file.java. Say this in folder.java file, right? And for example, here are some of the member variables that you might make, right? Quick note there, with the square bracket that you see on the red folder, that's array notation. Are you guys okay with array notation? You guys know what arrays are, right? They taught you that in O1S, I presume, or like the previous modules, hopefully? Yeah? Okay, so for example, for the folder class, we might want to do a few things. We might want to give it a name. We might want to have it, we might want to say that, okay, this has like potentially subfolders. We might want to do that using an array, right? We might want to say it contains some list of files. We might want to do that in an array. So this is how we would specify it. Yeah? Okay, and again, below that, we have our methods, which sort of specify the behavior of the class. Okay, so at this point, now that I've mentioned class and I've sort of brought up what an object is, quick question. What's the difference between a class and an object? Do we know? Because I've not specified it, right? Okay, so in the interest of time, I don't have much time to poll you guys, but TLDR, the class is a template for how to make an object. Think of it this way. You have a recipe for a cake versus the cake itself, right? The recipe for the cake is the class, right, which is the code that you write. For example, the code that you write, this is kind of the recipe, right? When you create the object, that's the object, right? So again, the recipe for a cake versus the cake itself is not the same thing. We can eat the cake, we can't eat the recipe for the cake. Well, I don't know about you, but I don't like eating paper, so, like, maybe you do, I'm not sure, right? But that's the idea. Does that make sense? Okay? Okay, so let's talk about creating objects. I said I will cover that, right? So for example, let's say I want to make a new folder object. How do I do this, right? If you remember the folder object, the constructor for this, okay, I'll flash it back to you guys in case you don't remember. I know I'm going a bit fast, I'm sorry. We don't have a constructor here, but okay, hypothetically, pretend that there is a constructor, right? How we will create it is to use this new keyword right there, right? So we say equals new, followed by the class name, in this case folder, and we have to provide in the name of the folder itself. Okay, so this is how you create objects in Java. Quick question, have you all used like new before? Like, no, right? So how, okay, I would love to poll you guys, but I don't have time. I keep looking at the clock and it's like, I don't have time. But this is how you do it now, yeah? Google it, like hopefully it makes sense. Okay, now, a few things to mention. This is called the constructor. It looks like a function, right? We call it, it's a special kind of function. We call it a constructor. This constructs the object. Think of it this way, you've written the class out. This constructor basically, in some sense, reads that recipe and creates the object based on that. So you can be rest assured that the member variables have been created. You can manipulate them. You can call functions using this, right? So let's look at the file class, right? And to specify a constructor, you would write the lines file open paren string file name close paren, right? Then you specify how you want your member variables to be initialized. Does that make sense? Right? This is literally you writing down, here's how I would like my object to be created. So when you write new file and you give me a string, this is what I'll do to my variables. And then it will give you an object with those things set. Yeah? It's definitely important to know this. The constructor function has to have the same name as the class. That is by convention. If you don't do this, you will not be able to construct. Okay, as in like if you won't be able to say new, blah, 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 whatever, right? It takes 0 or more parameters, right? It's called on object creation and is used to initialize the class, bunch of stuff, right? Okay, now I know there are many rules involving constructors, and you'll see some of this in CS2040S, right? So for example, a bunch of stuff like, okay, when is this actually created, about the memory and stuff like that. It's really complicated. We don't need you to worry about it. TLDR, you should know that this is how you should create an object, because sometimes you're going to create objects. When we talk about creating trees, when we talk about creating arrays and lists and stuff like that, creating linked list nodes and stuff like that, you need to know what a constructor is, but not to this much detail, right? Okay, so that sort of like rounds up my point on like how to make classes and objects, and hopefully that didn't go too fast, but please forgive me. Yeah, so that's kind of how it goes. Coming back to this picture, right? Yeah, just rounding up object-oriented programming. Okay, so few things to note. Why is this helpful for us, right? Let's come back to this picture where we talk about objects and classes, right? So I've mentioned that your data is sort of the things you see in the yellow box, and the behavior are the methods that you provide in your class, right? These are things that are callable. So how does this help us accomplish the two things that we wanted to talk about, right? The idea is the following. You can think of it in two ways. You can think of two aspects about this. The interface is how you interact with the object, right? So for example, your methods enter, leave, count, these kind of things are basically how you interact with the object. That's the interface, okay? The implementation details are hidden inside the object, okay? So that brings me to my next point about interfaces. You might have already seen similar code for your problem set. If you haven't seen your problem set yet, then hopefully after what I say here, it might make a bit more sense. Okay? So an interface is one way where you're not making exactly a class, you're making sort of a contract. Okay? So the way that it works is that instead of writing class, not a class, right? Instead of writing class, you write interface ifile. And how this works is that you specify only the function signatures, not the function implementations, only the function signatures, right? So you would write here, in this interface, for example, I want a rename method, I want a get data method, I want a set data method, right? And these things, you might also want to specify, well, you should specify the return type as well as the input types, right? So I reiterate my point, and you'll see how we'll use this in a bit. But the point is an interface is a bit different. It's basically listing out a bunch of methods that you need to implement, and there is no implementation in there themselves. Okay? Think of this way as basically saying, here is one way we would like to interact with our classes. So how do we use this thing? For example, let's say I have ifile. Read ifile as interface file, if you will. Right? So what we can do, for example, is to now create a class file again, but this time with the keywords implements ifile. Okay? So if we do this, you're basically telling Java, you promise to implement all the functionality in ifile. Right? So I have ifile in a small snippet here, right? And remember, we promised to implement 3 methods, right? The 3 methods are rename, get data, and set data. Okay, so what that means is that when we write the code for class file, right, we have to implement the three methods that we promised. Does that make sense? Right? You'll see why we use this in a bit, but just as another example, let's just say that we have another person who wants to implement another file class. One way they could do it is to write class other file implements ifile, right? And maybe this time in French. I think that's French. It looks like French, right? And then they would do the same thing. They would write whatever they want, but they have to implement the methods. So I have a question at this point. Let's say we wrote this code. Let's say we don't speak French, I don't know, but we wrote this code and we tried to compile it. Will it be okay? Who thinks yes? Who thinks no? Why not? Yes, exactly. We're missing a method here. We're missing rename. Yes, right? So for that reason, it's not good. And Java will complain. The Java compiler will literally stop you and say, hey, you promised to implement all 3 methods, but I only see 2 of them. Where is this method? I want its implementation now, right? So that's one of the reasons why we use an interface. It's a promise, okay? So what gain do we get from promising that we implement ifile? What gain, like what's the point of doing this, right? What's the point of implementing everything, okay? So let's just say that we have a different method somewhere else, and it's called copy file. Now, instead of specifying exact classes or exact types, I can specify the interface instead. I can promise you that in copy file, I will return an object that implements the ifile interface. And it also takes in an object that implements the ifile interface, right? This way, I don't care if you gave me whichever implementation of file you want, as long as it fulfills the promise that it implements ifile, we're all happy. Does that make sense? Yeah? Why? So how does this work? Let's say, for example, we have old file is given in as input, right? We are now promised that we can call the function get data if we need to. Does that make sense? Right? Because the promise is that it has implemented the iFile interface, get data is definitely well defined. We can definitely do this. Okay? Now, again, for example, let's say that we create a new file by ourselves. We call it file data. We create a new file called file or whatever, and we also promise that our file implements iFile. We can also return it. That's completely fine. In case I spoke too fast, let me put it this way. Look at the first blue line. We made new file. What is the type of new file? File, right? And we're returning it on the final line, right? Why are we allowed to do this when the return type of our function is iFile? Because the file class implements the iFile interface. Okay? Okay, so tying this back to the problem set, you might already see this. We have a public interface for this linear feedback shift register, right? This means that we want you to implement these functions, setSeed, shift, and generate, right? Which is why in your problem set code, you should implement those methods. Does that make sense? This is our way of making sure you fulfill your end of the implementations. Okay? Okay, so for a quick summary, so far we've covered object-oriented programming, right, to some degree, right, about interfaces and classes and stuff like that, okay? Next, a bit more in terms of Java details. Okay, so access control. Now, like I mentioned, typically we want it so that the behavior is public and your data is private. Okay, so we haven't talked about access modifiers, but typically, for example, you want to hide your data. So what you should do is basically set, you should write private in front of all of in general, in front of all of your member variables, and typically the functionality that you wish to expose, for example, rename, get data, set data, these things you should write as public because these are things that other people should be able to use from your class. Does that make sense? Right? Now, I have written here another example, let's say compressed data storage. Maybe this is a method that you want to use for your own implementation. After all, we all agree that we should write our code in small pieces, right, with small functions, and we should be able to reuse them. For example, let's say in our implementation of iFile, we had some stuff that we had to do. In our implementation of other file, we had some stuff we wanted to do, like compress, but we don't want other people to call that method for us, and we should only use it for ourselves. We should mark that method as private. Yeah? Okay, so by default, I think if it's, I forgot what the exact behavior is if you don't specify it, right? But if you explicitly write it, public means everyone can use it, private means only within the same class, right? There is something else called protected. Let me not get into it. You will learn that in 2030S. We're not going to use it in 2040S. Yeah? Okay, so to sort of illustrate my point, let's look at class A and class B. I know we're going to start calling them A, B. You're going to see a lot of A, B, and C's in your 2030S as well, I'm pretty sure. Or it'll be like animal, and then there'll be like cat and dog, and then there'll be one that goes meow, and the other one goes like woof. You're going to see that. Like Anyway, class A and class B. So for example, let's say class A has a private secret function that returns an integer, right? So this might be how we want to call the function. Right? We might want to say that we take example, which is an instance of class A, and we might want to call the method secret function. To do that, we take the variable name, we place a dot in front of it, and then we write the name of the function. Yeah? So the reason why this is an error, hopefully you're following along, is because that function, that method is private. So we're not allowed to do this. This is not allowed. Right? Likewise, if let's say that we had a secret variable in class A, and we've marked it as private, very similarly, instead of calling the function, if we want to access the instance variable, right, we're not allowed to do this because it is private. Okay? So at this point, maybe you're frustrated after you've seen this code and you think to yourself, okay, I'm going to fix this the way I know how. I set that to public, right? Maybe think twice about whether you should do that because it sort of breaks the idea of encapsulation, right? If something is really meant to be kept private, maybe you should keep it private and you should find ways to get around this. Maybe expose it using a getter and setter function, right? Okay, I'm preempting you guys on 2030S stuff as well, but anyway. One thing to note, for example, your constructor, now that we've talked about public and private, your constructor should almost always be public. There are special cases where it should be private. We won't talk about those, right? But think about it this way. If it's not public, how are we going to create your object, right? So very similarly, an interface should almost always be public, right? Interface method should almost always be public because you're specifying public-facing behavior. Okay, so TLDR again, you can skip, in my opinion, you can probably skip the first and last row. TLDR, public means everywhere accessible, private means only within the same class. Okay, my advice again, please specify the behavior explicitly, okay, because default behavior you don't want to assume. Okay, one thing to note, right, packages. You might at some point eventually come across packages, right? This is our way of importing functions and methods and stuff like that, right? So for CS2040S, we won't use packages, right? But let me talk a little bit about them. So in case you don't know, maybe something you might see and it intimidates you, right? This is how you import code. So for example, you have a file called clever code and it has like a bunch of classes. To import all the classes from clever code, this is one way you would do it. You would write at the top there clever code .star, right? Now, I think in your assignment, in your problem set, you might see some import lines here. Let me explain what they mean. Let's say, for example, you have a shift register. Clever code has a few things, a few classes, more than just shift register, but you only need shift register, right? It's good practice for you to just write clever code.shift register. This way you import only what you need. This is a lot cleaner, and it's also so that when other people read your code, they know exactly what you need, right? Imagine if someone else has to read your code, not during this semester, but when you're working outside and stuff like that, they look at it and they go like, okay, you imported everything. Are you using everything? Right? That's extra stuff they have to go through. Okay? Another example, further down the semester, we might use a hash map. Well, we almost definitely will be using hash maps at some point. Almost definitely, I can guarantee you. Right? How would you import a hash map? Right? How you do that is to write the line import java.util.hashmap. Right? On the problem sets, we will specify which ones you can use, stuff like that. But here's an example of how you would do that. Okay? So again, I've mentioned this already, but in general, please don't use libraries if it makes the problem set easier. If it defeats the purpose of the problem set, please don't do it, right? Even if you get by and your tutor hasn't said anything, are you really learning something? Are you really learning what we want you to learn, right? Okay, so rounding up a few more things, class versus object, right? I've already mentioned this, but basically the class is a template for how to make an object, and object is for a specific instance of the class, right? Okay, so think of it this way: if you haven't specified, you've written everything out so far, everything should be per object, which means your variables, your member variables are per object. You make two different objects of the same class. They're still two different sets of variables, right? You can use one recipe to make two cakes, right? But if you cut one cake, the other cake doesn't automatically get cut. Do we agree? Does that make sense? Right? Now, there is this thing called static, right? So static methods, on the other hand, are for the entire class. Okay? So for example, if I wrote public static, right, this static means it's not tied to any specific instance. Okay? So, for example, if I say I want to add an extension, give me a name, it returns the name plus let's say we append .pdf to it, right? This might be one way to do it. This is kind of fine, right? But what about this example where instead we access a variable name? A member variable. Is this okay? What do we think? No, right? Because static methods, on the other hand, affect all the cakes. Well, not to say all the cakes, but they are basically static methods. So, in other words, you can't use a static function to access a member variable. Yeah? Okay. How would you use static variables, let's say? So, for example, let's say you want to keep track of how many cakes you've made, right? For example, how many files you've made, right? So one way to do that is to use a static member variable, right? This way, every time a file is created, right, or maybe let's say you want to call increment, right, all of them reference the same variable. They all affect the same variable now, right? A static variable is affected by all of them. Okay, few more things. Let me quickly run through this. Okay, initializing an object, I think we kind of mentioned before. We've talked about this a little bit, right? But for example, if I wrote equals here with the on the member variables, this basically gets set, right? The other way to set your values is to use the constructor. Does that make sense? If I recall correctly, you might have to fact check me on this. If I recall correctly, the red lines are run before the constructor. I think. Yeah? This is what I mean. Constructor behavior is very complicated. Okay, let me skip this because I don't think it's too important, hopefully. Okay? Initializing an object with an array, maybe we should talk about this, right? So if you want to initialize an array and you have and the size is fixed, then initialization is simple. It basically does it. I think it does it in some straightforward way. But what if the size of the array is not known in advance? One way to do this might be to, for example, you might think that you should just take the number of pages, and we said that we just write that in the square brackets of the constructor, right? So this is one way to do it. This creates an array of size num pages, right? This is not statically defined, but basically that's the idea. Okay, one more thing to mention, the main method. So you might see this in most Java tutorials. They'll say that the first method you should ever write is the public static void main method, or we call that PSVM. I remember my friends used to have like on the editor, like when they type PSVM and they hit a special button, it just like expands out like the public static void main for them because it was so much to write. But basically, this is the main function. This is the function that gets run first in your Java code. Yeah. So not every class needs a main function. The main function is the starting point, the entry point for your code. Okay. For example, in this main function, we're going to create a root object, a folder object called root, and we're going to do that by calling the constructor using the lines new folder, right? And then, for example, we can create a file, and to do that, we're going to again use the constructor for file. We say new file, we pass in like what the constructor needs, which is a string, right? And then we can do something like, let's say, root.add file homework, right? So this adds the homework file into the root folder. Okay, at this point, let me quickly skip through a bunch of stuff. I mean, like, briefly show you a bunch of stuff, and then we can try to, like, finish. Okay, so the Java operators, you can look these things up, right? I don't need you to memorize these things now, and I hope we don't have to go through them all one by one. These do what you think they do, right? Again, about types, in case you're not familiar with this, these are the Java types that we have, right? You can, again, look them up. Okay, let me move through this. Okay, so a few problems you might anticipate about your problem set. You might have issues setting up the libraries or your IDE, right? Post it on Cosmology. We have tutors there to help you out, yeah? Again, if you have other issues, please let us know on Cosmology. But for example, a few common issues might be that your file does not run properly. You might need a main method, right? Make sure that IntelliJ is running on the right main method, right? Make sure that the file name is the same as the class. Read the error messages. They should tell you these things, right? In general, I think you all know this. You all should have experience, but in case you don't, if a file does not compile, the IDE might give you some red squiggles. Hover over them. They might give you error messages you should deal with, right? Check all the files in the project to make sure it's okay. Other issues, please, again, post on Cosmology and ask us questions, okay? If you want to find out more, there are web pages that that will walk you through the basics of Java. Hopefully, you can go through those and you'll be primed enough for the semester, right? And that ends my segment on how to sell you guys Java. Yay! Okay, so next week we'll do searching, like algorithms for searching, right? That ends my time here. Thank you so much.